You have homework 3 out. We're going to run through the last question, and then you're going to turn it in. Your notes today, we're not going to do all of them because we're on a short period. We're going to try to do examples off the homework. Okay? So this is a graph of velocity. How do I tell if the particle is moving to the right or to the left? What do I look for? Okay, positive or negative, which is above or below. Good job, Aaron. So if I want to be going right, I want 0 till 1, 2, 3. 0 to 3, because v of t greater than 0. Okay, also where else? This is 3, 4, 5, 6, 7, 8, 9. So also from 9 until 10, 11, 12, 13, 14, 15. So union 9 to 15. Okay, then it's traveling to the left from 3 to 9 because your velocity is less than 0. Okay, next question. We want relative maxes and relative mins. Which direction does a max have to change sign? Okay, 3 or 9. Which one then? T equals 3 because V changes from plus to minus. Okay, then your next one, I want a relative minimum. Where does that happen? 9 because V changes from minus to plus. Okay, next question. We want displacement. Absolute value bars or no? No. Displacement, you allow it to have the sign that it's going to have. Okay, then your areas are given to you. You don't even have to find them. What was your first area? 6. How do I count my 8? Plus or minus? Minus 8. How do I count my 7? Plus 7. 6 minus 8 is negative 2. Plus 7 is 5. Okay? Part E says to find the distance traveled. Distance is always positive, so you edit your integral with what? Absolute value bars. And so instead of allowing my minus 8 to be negative, I would turn it to a plus. So 6 plus 8 plus 7. That comes out to be 21. Hi. Thanks. Okay, then next one. Okay, now, did he say you had to take it down? Okay, I was like, I heard wrong. I don't know. Okay. What is the position? Now, this is important that you remember this. I don't know if you remember from when we talked about it. But position is not just the integral. You have to know where it started. So I'm going to make a table here. Time and position. And then I'm going to go back to the question stem to find the starting time. Okay, so come up here. What does it say? Where does it start? Okay, it says it starts already at 5 feet. So it didn't travel those 5 feet, but if that's where it started, you have to take that into account. So 0, 5 is your first point. Okay, then remember what goes in your chart besides 0, 5, all of the times it changed direction, which would be 3 and 9, and then the other endpoint, which was 15. Okay, then from there, from 0 to 3, my particle traveled 6 areas above. So that means it would end where? 11. Then from 3 to 9, it traveled 8 backwards, which puts me at 3. And then from 9 to 15, it traveled 7 forward, which puts it at 10. So what is the position at 15? 10. Okay, then your last two questions. Farthest to the right, is that a max or a min? That is an absolute max. Thank you. And then farthest to the left is an absolute min. Okay, now remember that your absolute min and max are the y values. They occur at time values. So my absolute max is what? 11, it occurs at 3. And then your absolute minimum is 3. It occurs at 9. Okay, good? Alright, make sure your name's on it. Go ahead and just kind of like pass it up and I'll get it in a second. Okay, I need you to get out your notes. Okay, really I just need one page in your spiral or whatever you take notes in. Okay, we are going to learn the trapezoidal rule.
Thank you. Wait, take out our notes?
Yep. Or just a blank sheet of paper.
Is yours in there? Chords.
I just have to turn in 2 years.
Anybody else?
I might turn in homework 2 to you next week.
Okay.
Wait, I need help on it. On a question.
Okay. Top of your notes, we're learning trapezoidal rule. Thank you. Yeah, you should be there. Okay, draw a graph. Remember that the integral from a to b of f of x dx is the exact area. So remember that we learned yesterday that you can approximate that area using rectangles, yeah? Okay, so I'm going to put A here. I'm going to put B here. I'm going to shade in the exact area. This should all look very familiar. This is how we started yesterday. Okay, that is my exact area. Now, if you use rectangles, okay, there's an obvious problem that you're always over or underestimating by quite a bit. So, a trapezoid, I don't know why I said it like that, a trapezoid, okay, is a better estimation. This is why. Split your graph up here and then here, just like we did yesterday. Draw your lines in to splice it up. And then when I draw a rectangle in, the top has to be flat across. So you always end up either getting way too much or way too little. A trapezoid is going to be a much better estimate because look what I can do with these. If I'm a trapezoid, I can connect them diagonally. And then here I can connect these two diagonally. And then these two, the way I'm drawing it, I can barely even see the error. There is still an error, but it's much less. Okay, and then these two connect. And so I would consider each of those to be a trapezoid, and I would find the areas of the trapezoids and then add them. Now let's label your y values. We'll call this y1, y2, y3, y4, y5. Okay, for trapezoid 1, okay, for this one that I'm going to highlight in green. Okay, how would I find the area? It'd be 1/2 base 1 plus base 2. Okay, now let's think about my bases for this trapezoid are going which way? This way. Okay, because remember that your bases have to be parallel to each other. So this is base 1, this is base 2. So I'm going to do 1/2 y1 plus y2. And then remember that my height, since my trapezoid is sideways, is going to be called my delta x. So put a delta x here. That'd be this distance here across the bottom. Okay? Now let's do our second triangle. I'll do this one in blue. Or not triangle, trapezoid. Okay, how would you find the area of the blue trapezoid? You do 1/2. What is base 1 and base 2 for the blue one? y2 plus y3. And then I would multiply by their delta x. Okay, now let's do my third trapezoid. Okay, 1/2. Well, they'll be in the table, so you'll know them. Or else they couldn't ask you to do it. Okay, what is my third trapezoid? This one here. y3 and y4 are my y value bases. Delta x plus. No, these are just continuing to be added. All of this would be your answer. Okay, and then for the last one here, okay, we'll do it, I don't know, in orange. Okay, what would the area be for that one? 1/2 y4 plus y5, and then delta x. Now, do you remember yesterday we did this with rectangles, and then eventually we said, okay, if the delta x is the same, we can shorten the formula by greatest common factoring the GCF out to the front. Do you remember that? Okay, what if my delta x is the same? So I'm going to put here, this is for unequal subintervals. So if they're not the same, you have to set it up the long way. Okay, but if you have equal subintervals, there's not only a delta x you can pull out, what else can you pull out? What do they also all have? A 1/2. So if you have equal subintervals, not only can you take out the 1/2, but you can also take out the delta x. Now let's talk about what would be left over when you remove all the 1/2s and all the delta x's. Ready? So my first trapezoid, 1/2 is removed, delta x is removed. What's left over? y1 plus, don't write that yet, y1 plus y2. Now from my second trapezoid, these are gone. What's left over? Another y2 and then a y3. So how many y2s were there? 2. Okay, now my third trapezoid, these are gone. I have a second y3 and then a y4. And then for my last one, I have a, oops, I crossed out the wrong thing, a y4 and a y5. So what I want you to notice is that each of these middle terms are going to get repeated. What are the only terms that didn't get repeated? y1 and y5. So in your shortcut, this is what you're going to do. y1 plus double y2, double y3, double y4, plus y5. Okay? And then remember, why does that happen? Because in my yellow trapezoid here, let's say we're talking about y3. It's the base 1 for yellow, and it's the base 2 for blue. So all of your middle y values get used twice because they're base 1 for one trapezoid, base 2 for the other. Got it? Okay, go to your notes. We'll do 2 examples off your notes, and then we'll work on your homework together. Okay, look at the first one. Okay, you have your chart. We're measuring in feet per second. Part A says, write but do not evaluate an integral expression to determine the distance traveled. Remember, distance traveled is the integral. So from 0 to 60 of v of t dt. Now, if you remember, technically, you should have absolute value bars, but since all your y values are positive, doesn't really matter. Okay, what is my first delta x from here to here? What about my next one? 2. Every time, what do you notice? Okay, you have equal subintervals. Your delta x is always 2. That means I get to use the short version. Okay, so you're going to put your 2 in the front. And then if it's a left Riemann sum, which y value gets skipped? The last one. This is why I think about, I'm on the left for 0 to 2, left for 2 to 4, left, 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 and then 65 is never the left side. So it'd be 5 plus 12 plus 21 plus 32 plus 45 plus 54. And then you're done. Okay, I'm going to put a little star here next to left. The last one gets skipped.
You don't have to add it. Can you just leave it as...
Yeah, you can just leave it like that. Okay, come down to part B. Part B says to use a midpoint sum. Do you remember for a midpoint that you have to leave a term in the middle? So instead of going from 0 to 2, I don't know what 1 is in the middle. So I have to skip 2 for a midpoint, and I have to go from 0 to 4. Now, from 0 to 4, what's my midpoint going to be? 212. Very good. Then from 4, I have to skip 6 and go to 8. That leaves 32 as my middle y value. The y value at 6. And then from 8 to 12, I'm skipping 10. 54 is my y value. Now, for your midpoint, since we skipped, what is my delta x? Okay, it is 4. Okay, because you're having to double those integrals so that you can leave 1 in the middle. Yep, so for a midpoint, we're going to go from 0 to 4, and then we're going to use the middle y value. And then 4 to 8, middle. And then 8 to 12, middle. Because from 0 to 4, how long is it? Yeah, and then from 4 to 8, how long is it? 4. And then 8 to 12, 4 again. Okay, so come down here. I'm going to put my 4 in the front. And then I'm only going to add the midpoint y values, which would be 12, 32, and 54. Okay, part C, this is new. We're doing the trapezoidal sum. Long version or short version? Short. Because we have the same delta x every time. How long is our delta x now that we're doing regular, not midpoint? It would be how long? 2. Okay, then open your bracket. And remember, my first and last y values only go once. All the other ones go twice. So it'll be 5 plus 2 12s, 2 21s, 2 32s, 2 45s, 2 54s, and then 1 65. Okay? Now, the 1/2 and the 2 can do what? Okay, they can cross out on that one. Most of them they can't, but if it is a 2, they'll cross out and be gone. Okay, turn please. I want to do one with unequal subintervals. Oh wait, check and see. There was an angry lady outside checking for passes. So just poke your head out. And if she's there, huh? I mean, I just don't want to write one. Is she out there? Okay, go. Okay, look at your gorilla question. Okay, now the reason I picked this one is because this one we can't use the shortcut. So if I'm doing skip to part B, okay, a trapezoidal approximation, okay, then I'm going to say the integral from 0 to 9, v of t dt approximated by. And I'm going to have to set up each trapezoid on its own because I don't have the same delta x. So ready? We're going to do the first one from 0 to 2. Okay, first question. I have 1/2. Then my bases are my y values. From 0 to 2, what are my y values? What are my y values? 3 plus 7. Okay, then your delta x is how far apart your x's were. Okay, 2. Very good. Plus. Okay, next one. I'm going from 2 to 4 this time. Okay, so I'm going to put my 1/2 in the front. Then what are my y values at 2 and at 4? Remember, 7 gets used again, and then 11. Then what is the delta x from 2 to 4? 2 plus. Okay, next one. Now we're going from 4 to 5. What are my y values? 11 and 12 are my y values. Don't forget your 1/2. And then what is your delta x from 4 to 5? 1. Okay, next one. We're going from 5 to 8. 1/2 goes in the front. What are my y values at 5 and at 8? 12 and 15. And then what is the delta x from 5 to 8? 3. Okay, then my last one plus from 8 to 9, what are my y values? 15 and 17. And then my delta x from 8 to 9 would be 1. Okay, and then you don't have to times or add it up. It's fine. You just leave it like that. Okay? Now, the last thing we need to cover, go back to your notes. Yes?
Could you be able to combine the ones with the same
You could. Sometimes that gets confusing, so I don't do it that way, but if it's algebraically the same and you do it correctly, then that's fine. Okay? Yes? For the first one? Oh, yeah. Y'all, look, that is true. Okay, what was my ending time value supposed to be on number 1? What are my time values from 0 till when? 12. So cross that out, put a 12. Thank you. Okay? Now, your homework that goes with trapezoidal rule does have a few questions on IVT. So we'll cover that here in a minute, but go back to your notes. Okay, ready? Normal notes on your paper. This one. Okay, remember that for rectangles, you can tell if it's going to be too big or too small based on which side you use and if it's increasing or decreasing. You remember that? Okay, for trapezoids, the way that you tell if it's too big or too small is based on concavity. So I want you to draw a concave up graph. Okay, and then a concave down graph. Okay, my concave up graph I'm going to draw right here. Okay, I'm just going to use a parabola. And then my concave down graph, I'm just going to use a parabola going down to keep it easy. Okay, let's put A and B here. And then let's put A and B here. So if I shade in my exact area, that's the correct value of the integral. Oops, I put my B too far. I'm going to stop it here. Okay, and then here to here. Okay, draw trapezoids into the concave up graph just like we did. And I want you to tell me if you think it's too big or too small. Okay, just do 2 trapezoids, don't do 4. So I'm just going to do 1 and 2 pieces. So it'll, because remember, the less pieces you have, the more error you're going to have. So if I draw my trapezoid into my concave up graph, I'm connecting these 2 y values. And then I'm connecting these 2 y values. How do your trapezoids come out? Too big or too small?
Too big.
Little bit too big. See this empty space right here? That's bigger than my actual area. So for a concave up graph, your trapezoids will come out to be an overestimate. Okay, now come to this graph, do the same thing. Here, just use 2 so that you have a more obvious. Okay, here to here. And then here to here. Okay, for that one, how does your estimate come out? Under, very good. So here I'm going to put trapezoids are an overestimate of area. For concave up. But for this one, trapezoids are an underestimate for the actual area if it's concave down. So trapezoids, you're checking concavity. But for rectangles, you're looking at which direction it's going. Okay. So let's take a look, please, at that gorilla question, and we're just going to finish it up. Okay, look at the very last part of that question. It says, part C, is your approximation an over or an underestimate or the exact value? Okay, how can you tell? What does it say about acceleration in that question? Acceleration is what? On Earth. It's negative. And if acceleration is negative, what's your concavity? Okay, very good. That implies that my graph is concave down, because remember that acceleration is the second derivative. So on a concave down graph, how will your trapezoids come out? Okay, if you're not sure, concave down, okay, that's this way. If I draw trapezoids in, I can see they're going to be a little bit too small. Thank you. Okay. All right, take a look at your homework. Okay, our goal is to get through 3 of these. We may only get through 2 just because of the short period. Okay, do number 1. Number 1. Okay, first thing that it asks you to do is to interpret the meaning of the integral. So, what do you do with your units? Do you remember? You multiply them, right? So I would do cars per minute multiplied by minutes. And then what's going to happen if it's cars per minute times minutes? You just get cars. So write your interpretation, then we'll check it. Sean, we're doing your homework.
Which one? 4?
5, the one you got today. Okay, the integral 0 to 15 represents the number of cars that did what? Okay, that passed through the traffic light. Over what time? Okay, very good. Pass through the light over 0 to 15, and then that would be minutes. Okay? Then we're going to do our integral, or our estimation. What rule does it tell you to use? Trapezoidal sum. Very good. So, I look at my delta x's, long version or short version? Okay, 3, 6, 9, 12, 15. What's my delta x? Since it's 3, I get to use the short version. Versus if it was changing, I'd have to use the long version. Okay, remember, in the short version, you have the 1/2 in the front and the delta x. What was my delta x we just said? 3. And then when I add my y values, the first one and the last one go once, everybody else goes twice. So it'd be 20 plus 2 31s, 2 28s, 2 24s, 2 22s, 1 21. And then do not waste time typing these into the calculator. I don't need you to do that. Okay, if it was free response, you wouldn't even have to do it on the AP test.
So what makes it the long version again?
Let's do a long version. Look at the very next one. Okay, what do you notice about your first delta x? How far is it?
Yeah, no, that's what makes it.
So what is it from here? 0 to 30 is 30. But then my next one, 30 to 40, is only 10. That's the long version. So if your subintervals aren't the same every time, that's when you have to do the long one. So I'll put a little star here. delta x's aren't consistent. So that means you have to do the long version. Okay, good question. All right, let's do the interpret first. Take your units, multiply them together. What is acceleration measured in? Meters per second squared. What is time measured in? Seconds. If I have meters per second squared times second, what's left over? Meters per second. So that would be how much what does meters per second measure? Velocity or speed. So for your interpret, you would say the integral 0 to 90 of r of t represents, oops, that doesn't spell represents, pretend. Okay, represents the number of meters per second that the velocity changed over 0 to 90 seconds. Okay? The integral represents the numbers of meters per second that your velocity changed over 0 to 90 seconds. Okay, now let's do it. First trapezoid. We're going from 0 to 30. So I would do 1/2. What is my delta x from 0 to 30? 30. What are my y values? 20 and 30. So I do 20 plus 30 times 30. Okay, next one. Yes?
Not to be an English grammar Nazi, you completely jacked it.
I know, yeah.
Repress.
We're just going to pretend, okay? From 30 to 40, what are my y values? 30 and 40. 1/2. 30 plus 40. Then what's my delta x between those? 10 plus. Okay, next one. Okay, from 40 to 50, what are my y values? 40 and 55. 1/2 still in the front. And then my delta x from 40 to 50 is 10 again. Okay, you have 2 more left. Do the last 2. 50 to 70, what are your y values? 55 and 65. What's the delta x between 50 to 70? 20 plus, last one, 1/2, 65 and 70, delta x of 20. Okay? So the only difference, long to short, is that the long version you have to write each one on its own. Now, some people will say, oh, I'm going to pull out the 1/2. That's fine. If that in your mind is easier, do it. It's not wrong, but it tends to get confusing when you do it pulling out on some and not on others. Okay? All right, number 3. This is going to be the last one that we're going to get through. We probably won't have time to finish. But I just want to go over this one. How do you find average acceleration if you have velocity? Yes, A-Rock. Okay, remember that acceleration is the derivative or the slope of velocity. You have 2 slopes. You have the derivative as a slope and then average rate of change. If you only have a table, you have to do average rate of change because there's no way for you to take the derivative if you don't have it. So you do v of 60 seconds minus v of 0 seconds over 60 minus 0. Okay? Okay, 31 over what? 60. And then what would your units be? This is meters per second. It'd be meters per second squared. Now let me show you why. It's meters per second over seconds. Those don't cancel out when you're dividing. So it'd be or meters per second squared like we did all last semester. Okay, last one. How many times did the car have to hit 38? It does. Look closely. If it gets to 40, yep, it has to hit it going up to 40, then it has to hit it back down going to 36. What theorem would you be using to do that? IVT. Okay? And we can do that. I don't think we really have time. Is it Berkner time ahead or below? It's okay. So we can do it? Okay. All right. So you would say IVT. It's current. They fixed it. Guarantees V of t equals 38 twice on 40 to 50 and 50 to 60. Okay, now some of y'all I've noticed you like to do the theorem completely separate twice. I'm not going to do that because it seems kind of like a bunch of repeats. So I'm going to say my graph is continuous. And then in my second step, I'm just going to list all three y values. So my v of 40 is 35. My v of 50 is 40. And my v of 60 is back down to 36. So I'm showing all three. And then in my last step, I'm going to say, okay, well, 38's between these two and these two. That's how you would combine into just one. So 38 is between v of 40 and v of 50, and v of 50 and v of 60. So you're saying, here are my y values. It goes between these two, and it goes between these two, then it has to happen twice. Okay? We are done. Okay, you have a long weekend, so you have homeworks 4 and 5. Those won't be due till Friday. You don't have one on Tuesday. I think you have one on Wednesday, but not on Tuesday. So you'll have 3 total. Have a good weekend! Have fun at the pep rally. Good luck.